So today or tonight's lecture, whenever you happen to be watching this, is over in behavior. Let me go ahead and apologize. I actually did this from my PowerPoints, but whenever I was watching the video playback on another video I already recorded, the background washed out, the colors were terrible, couldn't see anything really, so I had to change it to an all-white background, black text. A little dull, sorry about that, but it's the best that we could do. So, today we're talking about in behavior. The objective for today is to determine the in behavior of a rational function, and in parentheses I have horizontal asymptotes. So, we're going to be focusing on finding horizontal asymptotes of rational functions. But keep in mind, I want you to know this, you'll see later on in your mathematics career, that this is not the only type of in behavior that there is. There's other things such as slant asymptotes, etc. But right now we're focusing on horizontal asymptotes. So what are horizontal asymptotes? Well, say I have some rational function that I'm going to graph. So we've already talked about vertical asymptotes, and it appears that this function has a vertical asymptote right here. That is a portion of the graph, some x value, where this function never touches it, never crosses it. All right, so horizontal asymptotes are very similar, and if you notice, there's actually one right here at some y value. Okay, so horizontal asymptotes happen at a y value. Now, this is also a y value of this function where this graph never touches, it never crosses, it is undefined for the function at this particular y value. Now, we call this in behavior because if you look at the function as it goes to negative infinity, as well as it goes to positive infinity, we're trying to figure out what value is this function approaching. So to negative infinity, it looks as if it's approaching right where this line is. To positive infinity, it's approaching to where this line is. All right, so that is why we refer to it as in behavior. And it gives us a lot of insight as to what this function is actually telling us when we actually apply it to different scenarios. So, how do we find horizontal asymptotes? Woo, that looks like a lot. Go ahead, pause the video right now. I'll give you some time to copy it down, and I'll explain it in a little bit. All right, so when we're looking for horizontal asymptotes, there are three different outcomes that we can have. All right, so the first one says if the degree of the denominator is bigger than the degree of the numerator, we have a horizontal asymptote at y equals 0, which is the x-axis. All right, so when we're talking about the degree of the denominator or numerator, obviously we're talking about some polynomial. It has a leading term, and we're going to look at that leading term's exponent. All right, that is the degree that we'll be focusing on. So if the degree happens to be bigger in the numerator than the numerator, bigger in the denominator, sorry about that, than the numerator, we have a horizontal asymptote at y equals 0. The second situation we can come across is if the degree of the numerator is bigger than the degree of the denominator, then we have no horizontal asymptote. So if that leading term has a degree that is greater in the numerator than in the denominator, there's no horizontal asymptote. And in the last case, if the degrees are the same, all right, so say we have x squared at the top and x squared at the bottom, those are the leading terms, then the horizontal asymptote equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. All right? So those are the three different cases we'll come across. Now, you're probably thinking, Mr. Harrison, how am I going to keep all this in line, remember all this stuff? Well, I got somebody here for you that's going to help you out, a good friend of mine. He helped me out back when I was trying to figure all this out. And he goes by the name of Bobo Botany. All right? So, Bobo, my friend right here, I'm going to draw him for you, actually. This is Bobo. All right, Bobo's chilling. He's going to help us. He's going to help us figure all this out. So this is Bobo. Actually, I'm going to give him a high top. A little high top. A little high top for you. That's Bobo. Actually, we can give some shades. We swagging it out. No big deal. Doing some pre-calculus. No big deal. Swagging it out in shades. Stunner shades. All right, that's Bobo right there. That is Bobo Botany. And he eats D's. DC. No, not D's, anything else. It's DC. All right, well, this is a plate. Give me a plate right here. He's going to eat DC. Give him, ooh, that's ugly for it, but just hang with me. All right, that's the knife, spoon, it's ugly spoon, and then some water to drink. So Bobo here is going to eat DC. Now you're probably thinking, what in the world does this have to do with what we're talking about today? I guarantee you, if you remember this little acronym, our little friend Bobo Botany, he's going to help you keep all of this straight. So what in the world am I talking about? Well, Bobo Botany's DC is a nice little acronym that can help us remember what to do when it comes to horizontal asymptotes. So Bobo, all right, bigger on bottom, y equals 0. So if the degree is bigger on the bottom than on the top, so if it's bigger on the denominator than the numerator, then we have a horizontal asymptote at y equals 0. Okay? Now, you might be able to notice I actually spelled Bobo here with a 0 because sometimes people think instead of it being 0, it's actually 1. So they try to say there's a horizontal asymptote at y equals 1. Don't do that. All right? If it's bigger on bottom, then it has a horizontal asymptote at y equals 0. Bottom. If it's bigger on top, then there is no horizontal asymptote. All right? So if we have a bigger degree in the numerator than on the denominator, then we have no horizontal asymptote. And then lastly, eats DC. So if the exponents are the same, EATS, divide coefficients. All right, so if we have the same degree in the numerator as we do in the denominator, then we need to divide those coefficients. That will give us our horizontal asymptote. So make sure you copy that down. All right, we're going to look at some example problems in a second. All right, so the first example says find the horizontal asymptotes of the following. So here we have a rational function, f of x equals 3x minus 4 over x squared plus 2x minus 3. So let's identify the leading terms. In the numerator it would be 3x. In the denominator it's x squared. We look at the degrees. The degree in the numerator is 1. The degree in the denominator is 2. We have bigger on bottom, so that means we would have a horizontal asymptote at y equals 0. All right? Bigger on bottom, horizontal asymptote at y equals 0. Give you a second to copy that down. Pause whenever you feel it's necessary. All right, example 2. We have the rational function x cubed minus 5 over x squared plus 2x minus 3. Leading term in the numerator is x cubed. Leading term in the denominator is x squared. We notice the degree in the numerator is 3. The degree in the denominator is 2. We have bigger on top, so there is no horizontal asymptote in this case. All right, bigger on top, none. So you can either just say none, or you can say no horizontal asymptote. I told you this was easy. Bobo Botany's making our life easy. Example number 3. We have the rational function f of x equals 2x to the 4th power plus 6x minus 3, all divided by 5x to the 4th minus 7. So, again, looking for the leading term. In the numerator is 2x to the 4th, and the denominator is 5x to the 4th. Now, let me just pause right here real quickly. Normally, conventionally in mathematics, we will write polynomials from greatest degree to least degree. All right, now for some reason it's not like that. You should order it from greatest to least. That way you can pick out the leading term. So we said it's 2x to the 4th in the numerator. That has a degree of 4. And then we have 5x to the 4th in the denominator. That also has a degree of 4. Now in this case, we're going to use the EATS DC acronym. Exponents are the same. So we divide the coefficients. So notice that We have a coefficient of 2, a coefficient of 5, so we divide 2 by 5. Can this reduce to anything? Nope. So our horizontal asymptote is at y equals 2/5. All right. So just like we write vertical asymptotes as x equals something, horizontal asymptotes are y equals some number. All right. Y equals 2/5 would be the horizontal asymptote in this case. Okay, we're going to do one last example, and then we out of here. Example 4. We have the rational function that's given to us. Now, these are more of the complexity that you'll probably see. It's not going to be so apparent. Sometimes you'll have to factor, and sometimes you'll come across the answers that we see here. So, let's look at the numerator. Our leading term is negative 2x squared. That has a degree of 2. Now, what is the leading term in the denominator? Well, you see that it's actually factored out. All right. Now, what you could do is actually FOIL this, or use the box method to multiply this binomial times this binomial. Though we really don't want to waste time doing that, because we just want to figure out what is going to be the leading term. So notice that if we were to factor this out, it would be x times x, which gives us x squared, and then we're going to get some other stuff. But our leading term is going to be x squared. All right. So we have a degree of 2 in the denominator. So again, each DC, exponents are the same, so we'll divide coefficients. So since we have x times x, which gives us x squared, we have a coefficient of 1. In the numerator, we have a coefficient of negative 2. So our horizontal asymptote is going to be at negative 2 over 1, which we can just write as y equals negative 2. All right, so that's more of the complexity that we're going to begin working with in class. It's not going to be as straightforward as the other ones, but that was just kind of giving you some examples, some groundwork as to what to expect. All right, so we'll pick up with this when you return to class.